Good morning, everyone. So, friends, this is a very important prerequisite session for anyone who want to learn computer programming. So, before learning computer programming, whatever may be the programming language, it can be C, C++, Java, anything. So, if you are a newcomer to programming, if you are a beginner to programming, one should know few basic things which are not directly discussed under any programming language. So I call them as prerequisites for programming. So in this particular lecture, we are going to understand few important things. One is first of all, what is the need for programming? If we don't know what is the need for programming, we don't understand programming at all. We don't understand programming at all. So if we understand what is the need for programming, then we have a reason to learn programming. So in this lecture, we are going to understand three important things. One is what is the need for programming and evolution of programming languages and programming paradigms, right? Then there is another important concept called as memory addressing, because you take up any programming language, you write any program, the two basic elements of any program are code and data. And if you don't know where the data gets created, how the data is saved, you don't know how to process the data. Ultimately, we write programs, we write code to process the data. So if we don't know how and where the data gets created, where the data gets saved, it is very difficult to process the data. That is the reason there is a concept called as memory addressing, because our data gets created in main memory, which is also called as RAM. So we should understand how the main memory is organized so that we get a firm understanding of how the data is created and how the data is stored, how the memory addresses are generated. Then it will be easy for us to understand programming. So these two topics are the fundamentals or prerequisites to learn in computer programming or any programming language. So in this lecture, we are going to discuss these three topics: need for programming, evolution of programming languages, programming paradigms. And in continuation to this one, in the next video lecture, we will understand memory addressing, which is a very important concept. Then we will go for computer programming. We will understand computer programming, or we will implement computer programming using a language called as C programming language. So this is how we plan our computer programming video lecture series. So this will be our session 0, or your prerequisite session, you can say. So let us try to understand need for programming and how programming languages evolved and what do you mean by programming paradigms. So first one, a need for programming. So why do we need programming? Why one should learn programming? There should be a reason, right? So let us assume, right? Suppose if I ask a question to any person, like what is 4 into 2? Immediately I'll get the answer 4 twos is 8. Similarly, if I ask a question, what is 8 into 4? Immediately I'll get the answer 32. But if I say what is the product of 1497 and 1497 into maybe 7896. Now, if my question is like this, I ask this question to any person, or even if I want to answer this question, I can't give you the answer immediately. So I can't give you the answer immediately. Similarly, similarly, suppose I ask you a question, what is 898 into 754, something like this. So how difficult it is to give the answer immediately, right? So there are two problems here. Suppose when I was asking what is 4 into 2, what is 4 twos? 4 twos is 8. I got the answer immediately and correctly. And if I say what is 8 fours, 8 into 4, the answer is 32. Anyone can give the answer immediately and correctly. But as soon as the size of the number increased, if it is a two three digit numbers or two four digit numbers, right? One needs more time. No one can give the answer immediately. And one more point, what is the guarantee that every time the answer is correct? Suppose if you say 1497 into 7896, probably you may need a pen and paper to do. I'm sorry. Probably you may need pen and paper to solve this product, and it will take more time. So as the size of the number increases, the time taken to perform that multiplication will also increase. But there is always a possibility like you may commit a mistake and you may end up giving a wrong answer also. So suppose if I write a program, computer program, and if I use a computer program to perform multiplication, irrespective of the size of the numbers, whether it is a 2 digit number or a 3 digit number or a 4 digit number, computer will give you answer immediately. So computers are very, very fast and accurate. Computer will not give you a wrong answer, right? So friends, the moral of the story is computers, let me make this statement. I hope everyone will accept this, because just now we have seen, right, by asking multiplication questions like 4 2 is 8, 8 4 is 32, but 1497 into 7896, it will take a lot of time. So immediately you can't give the answer, and there is no guarantee like you will give correct answer. Similarly, 898 into 765, it will take some time to do the multiplication and give the answer, and always there is a chance or possibility that I may give wrong answer also. So if it is a program, if it is a computer program, whether you give a 2 digit number, 3 digit number, or a 4 digit number, the moment you press enter button, it will give you the output immediately. So computers are very, very fast. Computers are very, very fast and accurate than us. It is proved, right? So one should accept like computers are very fast and accurate than us. Now the point is, if computers are very, very fast and accurate than us, so why can't we use computers to perform these calculations and computations? So when I wanted to use computer, because it is proved like, okay, computers are fast and accurate than us, that is great, accepted. but but how do I use them? I want to use, because computers are very fast and accurate than us, so I want to use computer to perform some task for me. So now the challenge is, how do I give instructions to computer? So this is the challenge now. So how do I instruct a computer, right? So I have to give command like the way I was asking you questions like what is 4 into 2, what is 8 into 4. Similarly, I should instruct computer to perform multiplication of these two numbers, right? So how do I instruct a computer? Can computer understand English? Can I talk to computer in English language? No. So how do I instruct computer? That is the challenge. In order to address this challenge, first of all, we should understand what is a computer. Yes or no? We need to understand what is a computer, right? So friends, how do I instruct a computer? So first I need to understand what is a computer. Computer is an electronic device, right? Everyone is aware of this fact, like computer is an electronic device. So what do you mean by this statement? Computer is an electronic device. What do you mean by this? Computer is an electronic device. So what do you mean by this? Electronic device, it can sense only two things. It can't understand any language. Computer is an electronic device. It's a device. It's not a human being, right? So it's a device. So it can't understand any language, but it can only sense two things. Computer is an electronic device and it can sense only two things. It can sense two things. Two things. What are they? Presence of voltage. See, it's a device, right? It's not human being, it's a device. So it can only sense presence of voltage and absence of voltage. Presence of voltage and absence of voltage. Okay. So it's a device. Obviously, it can only sense these two things: presence of voltage and absence of voltage. Presence of voltage is treated as 1. Please try to understand. Presence of voltage is treated as 1 or represented as 1, and absence of voltage is treated as 0. This is how, or because of this reason, computer can only understand the codes or the instructions which are formed using ones and zeros only. So computer can understand only the instructions which are formed using ones and zeros. Why only ones and zeros are used? Because computer can sense only two things: presence of voltage and absence of voltage. So I use combination of these presence and absence of voltage. I use different combinations of these ones and zeros to represent different instructions to the computer. So what is computer? Computer is an electronic device. It can sense only two things, that is presence of voltage and absence of voltage. Presence of voltage is treated as 1 and absence of voltage is treated as 0. So what computer will understand? Computer will understand instructions which are in the form of ones and zeros. So computer instructions are in the form of ones and zeros, which we call them as binary binary instructions, right? So everything which is represented to a computer should be in the form of binary instructions. So the language which computer can understand is language of ones and zeros, right? That's the reason the language which computer can understand is called as binary language. Language understood by the computer is called as binary language because it contains all binary instructions only. So I hope till this point it's clear to everyone. So language understood by computer is called as binary language. Right, friends? Now the challenge is, so again we go back to our first question from where we actually started. So we started with a point like computers are very, very fast and accurate than us. There is no doubt in that. So I want to use computer. That is the point, right? Since computers are very, very fast and accurate than us, we want to use computers. That's great. So we want to use computer. That's okay. Now the point is, how do I use? How do I instruct a computer? That was the question, right? We were discussing the same thing. Since computer is an electronic device, I have to give instructions to computers using ones and zeros, and the language understood by the computer is called as binary language. Fine, that's okay. Now how do I give command to computer? I should know binary language, right? So computers are very fast and accurate, so we want to use computers. That's okay, that's fine. Now the point is, how do I instruct computer in binary language? So let us try to understand the difficulty here. Let us try to understand the difficulty here. Then you will understand how programming languages actually evolved, right? For example, For example, I want to multiply 4 and 5. Now, in order to give this instruction to computer, I should convert this 4 into a binary number, binary form. 5 should also be converted into its binary form. Then for multiplication, there should be a binary instruction which I should remember. Then by using all these binary codes, I should give command to the computer. Means I should know binary form of 4, I should remember binary form of 5, and I should remember the binary code for multiplication operation. Similarly, if I want to do addition, I should remember the binary code of the data, and I should also remember what is the binary code of addition operation. For example, in a computer, if there are 15,000 operations that are possible, then I should remember 15,000 binary instructions of that computer. Yes or no? So how difficult it is for us to remember these many binary codes and then talk to computer using binary language? It is very, very difficult. And computer can't understand anything else apart from binary language. This is the problem. So can I interact with computer using binary language? No, it is very difficult. Can computer understand anything else apart from binary language? No, computer will understand only binary codes, right? So let me write these two statements. The summary is, please observe. So please observe these two statements, observe them carefully. Computer cannot computer cannot understand anything apart from binary language. But user cannot instruct computer using binary language, because just now I gave you an example how difficult it is to remember binary forms of all data and binary codes of all instructions. Like addition will have a binary code, subtraction will have a binary code, multiplication will have a binary code. Like that, how many binary codes I can remember? So talking to computer using binary language is very difficult for us, and computer can't understand anything else apart from binary language. So this is the problem. So to solve this problem, we use we take help of something called as high level English like programming languages. So to solve this problem, this is how programming languages came into existence, sir. So you, I hope you understood what is the need for programming, because computers are very, very fast and accurate than us. We wanted to use computer, but in order to use computer, I should talk to computer in binary language, which is very, very difficult for us. That's the reason. And computer can't understand anything apart from binary language. So what should I do? I can't learn binary codes, and I don't want to use binary language, but computer don't understand anything apart from binary language. So this is a problem here. So to solve this problem, high level English like programming languages came into picture, right? So this is how programming languages evolved. This is how programming languages evolved. So let us talk about evolution of programming languages. So I hope you understood the reason behind, or so first you understood what is the need for programming. Second, you understood why programming languages came into picture, right? So so the logic is very clear, the reason is very clear why programming languages came into picture. Programming languages are high level English like languages which are easy for us to learn and represent the instructions, and they will be converted or translated into binary code or machine code which machine can understand. So evolution of programming languages. Right. So just read it. Programming languages are high level English like languages which are easy for humans to learn and use. These programs, which are written in high level languages, will be converted or translated into binary language or machine language, which the machine can understand and execute them. So, this is how the programming languages came into existence, right? So, the entire journey started with a single point, that is, the point is computers are very fast and accurate than humans, so people wanted to use computer to solve complex problems. But in order to talk to computer, you should know the language of computer, which is binary language, and it is very tough for us to use binary language. That's the reason we use high level English like programming languages to write our instructions or programs to the computer, and these high level programs should be converted into machine code, and it is done by translators. There are different types of translators like compiler, interpreter, etc. So we use them to convert our high level program into a machine code where machine can execute them and it can give you the results. So this is how programming languages came into existence, right? And the next topic is programming paradigms, right? Programming paradigms are nothing but the programming concepts or ideas based on which lot of programming languages were developed, right? So there are so many programming paradigms, but there are three famous programming paradigms which we will try to discuss now. Friends, programming paradigms like procedural, structured, as I told you, there are so many other programming paradigms like functional programming, right, etc. But majorly procedural programming, structured programming, and object-oriented programming are very popular, and we need to understand them. So programming paradigms, there are three types: procedural programming, structured programming, object-oriented programming. I repeat, these are not programming languages. These are programming concepts or ideas based on which lot of programming languages were developed. So procedural programming is one idea or a concept. Structured is one idea and concept. Similarly, object oriented. So based on this, lot of languages were developed. So before we move on, let us define a program. What is program? Program is nothing but set of instructions. What is an instruction? Instruction is a command given to a computer, right? So what a program contains a set of instructions. And I already told you many times, again I'm telling, the two basic elements of any program are code and data. Please remember this statement. This is very, very important. Two basic elements of any program are code and data. Two basic elements of any program are code and data. Keep this point in your mind. Now, the two basic elements are code and data, right? Now, procedural programming, coming to a concept or ideology called as procedural programming. In procedural programming is an idea, right? So, in procedural programming, the entire importance, focus, and emphasis was given to code. Means uh, they used to write programs with more importance given to code, and it is called as code centric. Code centric, right? And one more important point which is related to procedural programming is procedural programming is similar to a student writing an essay, right? I want to give an example so that you can easily understand what is the concept of procedural programming. Procedural programming idea is similar to a student writing an essay. So what generally a student will do when he is writing an essay? Suppose the student has to write 10 pages of essay. And what student generally does when he is writing 10 pages of essay? Suppose there are some 4 or 5 lines or one paragraph which is used in page 1, and it is very, very important, and maybe it came 7 or 8 times in the entire essay. So what generally the student will do? What is the mindset of a student? Student will try to rewrite that paragraph wherever it is required again and again, so that he wanted to increase the size of the essay also, right? And most of the time you don't even remember, like that paragraph was already written. So if it is required again and again, student will write it or use it again and again. So if that one paragraph is required in 10 different places in my entire essay, we will use that 10 times. Means I'll write that paragraph 10 times again and again in my entire essay. So if this kind of repetition, unnecessary repetition is there in your program, then it comes under procedural programming concept. Friends, similarly, same example we will take. Instead of student writing an essay, imagine if an author writing a textbook. You might have seen textbooks, right? Generally, what authors will do, suppose there is one paragraph which was uh, explained or discussed in chapter 1, and maybe in chapter 7 again that paragraph is required. So what author will do? What author will do? Do you think author will write that paragraph again? No. What author will do? What author will do? Author will write refer so and so page number, so and so topic number. Like that, author will give a reference instead of copying that entire paragraph again. So wherever this important paragraph is required again and again, what author will do is author will simply write refer page number so and so. So structured programming is similar to an author writing a textbook. So what is the difference you have noticed in a student writing an essay and an author writing a textbook? The difference is unnecessary repetition of code was found in procedural programming, whereas in structured programming, you will reuse the code which was written in the past and it is useful again and again. Means you try to reuse it. And in structured programming, we can divide our problem into sub problems and we can solve them separately. If one of the sub problems solution is helpful to solve some other sub problem, we will not write that code again and again. We will reuse the sub problem, previous sub problems code, to solve any other similar sub problem. So code reusability, and there is a well defined structure to your program. So that is the difference between structured programming and procedural programming, right? And even structured programming is also code centric, means importance and emphasis is given to code, not to the data. Common point between procedural and structured programming is both are code centric. And the difference is, in structured programming, you have a well defined structure for your program, and there is a concept of dividing the problem into small modules. Modularity can be introduced, structure is there, and reusability of code. Unnecessary repetition of the code is not there. So structured programming is, you can say, comparatively better than procedural programming. But uh, as far as basic elements are concerned, both programming ideas, procedural and structured programming, both are code centric. And C programming language comes under, both, because even C programming is based on code centric theme only. But majorly it's a structured programming language. Since it is also code centric, you can say it comes under procedural also. So that C comes under both procedural and structured, majorly a structured programming language, right? But the main important point is, it took 30 to 35 years for people to understand a basic fact, like code is not more important. It is data which is more important than code. When people realized like data is more important than code, then a different programming approach, a different programming idea, different programming paradigm was required. And then came object oriented programming into existence. It came somewhere in 1980s, right? So object oriented programming is data centric. There are languages like C++, Java, Python, EFL, Smalltalk, etc. They are all object oriented programming languages. So object oriented is data centric. And the fact is, out of these two basic elements, code and data, which one is more important? Means obviously data is more important, right? Why data is more important than code? We will try to have an elaborated discussion in one more exclusive video lecture, which will be prepared to understand, is code or data, which one is more important. So that will be covered in an appropriate video lecture. As of now, what are the three fundamental programming paradigms? Procedural programming, structured programming, object oriented programming, right? And C programming language comes under structured programming language. So friends, I hope in this video, right, you understood what is the need for programming, because without understanding the need, you don't find any kind of interest in learning the programming. So do we really need programming or not? Yes, I need programming. Then what is the challenge? How do I use computer? Because computers are fast and accurate. Then how do I use them? I can't talk to computer in their native language, binary language. So I need something else. That something else is nothing but your high level English like programming languages. So because of this reason, programming languages evolved and programming languages came into picture. But when programming languages came into picture, they came under different themes or paradigms, which we call them as procedural programming, structured programming, object oriented programming, etc. So this is what is need for programming and how programming languages evolved. C comes under which category, and what are the three fundamental programming paradigms? All these three things were discussed in this video lecture. I hope this is clear to every one of you. And please leave your comment. If you have any doubts, you can please type in the comment box, give your comments, and I'll try to respond to your questions, right? So leave a comment if you have any doubt. And if the concepts are very clear, please don't forget to like and subscribe the video. And in the next video lecture, we will talk about memory addressing. So friends, as I told you in the beginning of the lecture, these two video lectures, these two videos, first one need for programming and the second one is memory addressing. these are basics which are required to learn computer programming. So I hope you enjoy this video. Please don't forget to like and subscribe the video. And if you have any doubts, post in the comment box. I'll be responding to them. And in the next video lecture, we will talk about memory addressing, which is very, very important. And without understanding memory addressing, you cannot go for programming at all. So friends, I hope this video lecture is useful for you. And in the next video lecture, we will talk about memory addressing. Thank you.